I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we'll solve one problem by using k-means clustering algorithm using Manhattan distance metric. First, we'll see the example problem question. The question is, all shopping malls have food courts which might include dishes like those given below. Use k-means for clustering into three clusters by considering the Manhattan distance metric. Suppose that the initial seeds are given as F4, F7 and F9. And this is the table given in the problem. This is the food ID and it has been divided into 5 columns: food ID, item, calories, carbohydrates and proteins. And the food IDs are given as F1, F2, F3, F4, F5, F6, F7, F8, F9, F10. And the items are aloo curry, cabbage, pumpkin, matar paneer, chana dal, moong dal, besan curry, gofta curry, milk, cheese. And the calories are being given like this. And this is the carbohydrates. And the final column represents the protein values. Here, what's our question is, apply k-means for 2 iterations. Trace the following intermediate results at the end of each iteration. Find the new clusters formed and calculate the centroid for new clusters. See, the question is, suppose the initial seeds are given it as F4, F7 and F9. And how many iterations are given? 2 iterations we have to go for it. So first we have to consider the clusters are F4, F7 and F9. What is F4? Here F4 is the Matar Paneer and F7 is the Besan Curry and the F9 is the milk. So we have to consider all those things and we have to solve the problem. So apply the k-means for 2 iterations. Trace the following intermediate results and the end of each iteration. Find the new clusters formed and calculate the centroid of the new clusters. So we'll solve the problem. First step, we have to find out the initial centroids. So what is the values are given? F4, F7 and F9. So F4 we are considering it as C1, cluster 1. F7 is considered as C2, cluster 2. And F9 we are considering it as C3. What is the F4 values? 3 column values. We have to take calories, carbohydrates and proteins 147, 11 and 7. Next we have to consider the C2 cluster is F7. We have Basin got it 100, 15, 3 and the finally C3 is initialized as F9. That is milk 67, 4, 3. So in this case, first we have to, the initial centroids we have to find out. So in the first step, step of k-means clustering, we manually select 3 initial points as centroids, also called seeds. What are the seeds? F4, F7 and F9 from the given data. These serve as reference points for measuring how close or far other point foods or etc. In this case, C1 is initialized as F4, Matar Paneer with coordinates 147, 11, 9. And C2 is initialized as F7, Basin Gaudi with the coordinates 100, 15 and 3. And C3 is initialized as F9, that is milk with the coordinates 67, 4 and 3. Each of these centroids represents a cluster C1, C2 and C3. The goal is to assign every food item to the nearest centroid based on the Manhattan distance metric, which is the sum of the absolute differences between corresponding features, calories, carbohydrates and proteins. These assignments form the clusters. And the next step is the calculate Manhattan distance. So the Manhattan distance is given by, so x1 minus x2 plus x2, that is y1 minus y2 plus z. So that is the Manhattan distance. We have to subtract and we have to take the square root modulus. First, aloo curry, the points are what? 105, 15, 1. It has been given in the table 105, 15, 1. For that, we have to find out the distance. So what is the value of C1? 147, 11 and 9. 140, this 105 should be subtracted from 147. and 15 should be subtracted from 11, 1 should be subtracted from 9. If you are taking the modulus for this, we are getting 42 plus 4 plus 1 minus 9 is what? Minus 8. Minus 8 modulus, if you are taking, we have to remove this value. So 8 here for this 4, and this is 42. So if you are summing up all the values, we are getting 54. And similarly for C2, it has been given 105 minus 100, 15 minus 15, 1 minus 3 is equal to 5 plus 0 plus 2 is equal to 7. And for the distance to C3, F9 is 60, 1 minus 67, 15 minus 4, 15 minus 4, 1 minus 3. So we are getting the value as 51. So among these three, we have to select the minimal value 54, 7, 51. If you are comparing these two values, which one is the minimal value? 7. What is the cluster? So the assigned cluster is C2. Similarly, for cabbage, if you are finding out, we are getting 27, 140, that is 40 and 68. So which one is having the lowest value? 27, C1. Similarly, for pumpkin, 91, 42, 4, and 4 is the minimum value, 60, C3. Similarly, 0, 57, 93, C1. So if you are finding out all the value, if you are taking cheese, 348 minus 147, 6 minus 11, 24 minus 9. If you are summing up all the values, taking the square root and the modulus, and we are getting 221, 278, 304. Among these three, which one is having the lowest value? C1 is having the lowest value. So the smallest value, first one, if you are taking the first column, the smallest value is 7. So F1 is assigned to cluster C2. Cluster C2. This process is repeated for every food item, and the assigned cluster is the one with the minimum distance. That we have to ever remember. Next, after iteration, where we are going for us, the distance table we have to find out. The distance table we have to go for it. Before that, we should understand C1. C1 comes under where? C1. So F2, F4, F6, and F8, F8 and F10. And C2 is F1, F1, F5, and F7. C3 is F3, F3 and F9. See here, the values of the clusters after iteration 1, we are finding out these are all the clusters. After iteration, after all distances are all calculated, we form the clusters as C1 is or F2, F4, F6, F8, F10, and C2 is F1, F5, F7, C3 is F3, F9. So each cluster now contains the points that are closest to their respective centroid. This completes the first iteration. Next, we have to recompute the new centroids. How you are going to compute the new centroids? We have taken for centroid of C1 as by considering, because it has been given for C2. C1 we found out F2, F4, F6, F8 and F10. All the values we have to take. The color is, if you are taking F2, F4, F6, F8 and F10. So F2. What is the F2 value here? So all the values if you are taking, so 131, 147, these values F1, F4, color is alone we have to consider. So here, color is alone F1, what are all the values? F1, F4, F6, F1, F1, F4, 147, F6 to 11. Like that we have to add all the values. How many values are there? 1, 2, 3, 4, 5 divided by 5. Centroid. Average we can call it as. Carbohydrates 7 plus. If you are adding all those values, for carbohydrates, how you are going to find out? F2, F4. So this is 7, 11, like that. You have to add the mid value and we have to find out the centroid. Similarly, protein values. So 2 plus 9 plus 13. So 10 plus 10.2. Similarly, centroid 2, whatever the values we got it, F1, F1, F5 and F7. So F1, F5, F7. We have to consider the first column, second column, that is second value, third value. All the values we have to sum up and divide by 3 because 3 values only there. So we got it. And the centroid of C3 is F3 and F9. F3 and F9. F3 and this is F3 and F9. So 67 plus 67 divided by 2, 7 plus 4 divided by 2, and 2 divided by 2 plus 3 divided by 2. We got it, right? So 2.5, 5.5, 67. So these values we have to consider. These values only we have to consider. These values we are calling it as the centroid. So we are recomputing. So in k-means, after assigning points to the clusters, we recompute the centroids based on the average of all points in each cluster. This is done for each features, that is calories, carbohydrates, and proteins. So we got these values, and next we have to go for by making use of these values, we have to go for the second iteration. So we have to go for distance from the new centroids. So with the new centroids, we repeat the distance calculation using the Manhattan formula. This time each food item distance is calculated to the new centroid positions. Let's take F1 again. So 105, 15 and 1. The distance to C1 is, so this values only we have to take. C1, so 196.8, 13.6, 10.2. For C2, we have to consider 101.3, 14.3, 3.0. For C3, we have to take 67.0, 5.5 and 2.5. We have taken, and here 105 minus 196 plus modulus of plus 15 minus 8, that is 13.6 plus modulus of 1 minus 10.2. So if you are summing up, taking the modulus, we got 102.5. Similarly, C2 and C3, if you are comparing all those values, C2 is having the less value. So C2 we got it. So this is similarly for this 80.6, 38, 66, C1 is having a lowest value. So that we have taken. And similarly for this case, so 144, 42 and 2.0, we got C3. And similarly, if you are taking the final 172, 276 and 304, so this is the lowest value C1. So in this case, this is done for all food items and the new assignments are determined. It's a repeat of iteration 1, but with updated centroids. See, the previous case, what is the centroid initially we have taken? 147, 11, 9, 100, 15, 13, 3, 67, 4, 3. After finding out this first iteration, we found out the centroid. By making use of the new centroids, we found out the Manhattan distance. So these values are known as the updated centroids. Next, this is the distance table. The table shows the distance from each food item to the new centroids. As before, the item is assigned to the cluster with the lowest distance. For example, F3 has minimum distance of 2.02 here, 2.02 C3. So assigned to C3 again. Similarly, F6 has minimum distance of 34.4. So we got a C1 is assigned again. F6, C1 is again. So 34. Similarly, F7 has minimum of, what is the minimum value? 105, 2 and 43. We got 2.0 is the less value. Assigned to C2 again. Each row reinforces the assignment decision based on minimal distance. So the final clusters after iteration 2. Once the assignments are completed, we find that the cluster did not change from the iteration 1 to iteration 2. So again the C1 is having, where are the C1s are? F2, F4, F6, F8 and F10. In the previous case also we have got the same value. Similarly F1, F5, F7. So in this case also F1, F1, C3 is F3 and F4. So this means the algorithm has converged. The centroids no longer shift significantly and the data points remain in the same cluster. Hence the clustering process is complete. Complete means if you are getting the second iteration also, whatever we got it in the first iteration, if it has been repeating, we are coming into the conclusion that the previous iteration, comparing with that, the algorithm is, what we can say, the algorithm has converged. Hope all have understood the simplest problem. The remaining things we'll discuss in the next lecture. Thank you.